Hello everyone, what's going on? I have another video for us for P3, Prerequisite Section 3. This is focusing on radicals. So the last video we hit these first three objectives. Today we are going to focus on the last objective, rationalizing denominators, as well as a little bit of simplifying because we have to practice multiplying radicals. So we're going to start with that first, this next example, so you can continue your notes from the last video, which was example 1. Here is example 2. So let's take a look at multiplying radicals. So what do we need to do? Here it says 2 times 4 plus the square root of 3. Now, this should look familiar. What do we need to do when there's a number on the outside of parentheses, right? Anything that comes to mind, hopefully something like distributing, right? So what we need to do is we need to take this 2 and distribute it to the 4 and also distribute it to the square root of 3, right? Common thing when we need to distribute. So distributing is the operation of multiplication. 2 times 4 gives me 8. 2 times the square root of 3. We can't multiply a number and a square root together real nicely. So what we need to do is write it next to each other like this. 2 square root 3, right? And then there's nothing else I can do. There, we just multiplied radicals. If we have like terms, we'll combine like terms. If we can multiply them together, we'll combine them a little bit further. But there is our final answer. Okay, 8 plus 2 square root of 3. There's nothing else I can do with that. Can't combine it because one has a radical, one doesn't. Let's take a look at another example that might be a little bit more challenging. 1 plus the square root of 5 times 4 minus the square root of 5. What does this look like? What do we need to do? What's the process we do when we are multiplying two binomials together? Two parentheses with two terms in each of the parentheses. Hopefully something like foiling comes to mind, right? Foil, first, outer, inner, last, and that's exactly what we're going to do. So the first thing, we're going to multiply the first number. So 1 times 4. 1 times 4 gives me 4. Okay, that's the first. Then we need to do outer. 1 times negative square root 5. Remember from above, they don't multiply together real nicely. We just have to write them next to each other. Inner, we need to do square root of 5 times 4 gives me 4 square root 5. We put that whole number in the front. And then last, square root of 5 times negative square root of 5. Watch those signs. Notice I have the square root of 25. How do you think we got that? When I'm multiplying a radical by a radical, we multiply the radicands. We multiply what's under the radicals. 5 times 5 gives me 25. The square root bar stays. From here, guys, all we do is simplify, okay? We need to focus on combining like terms. Notice right here, both of these terms have the square root of 5, right? Negative 1 square root 5 plus 4 square root 5. Think about those as like terms and really just focus on those numbers in front, right? Negative 1 plus 4. Negative 1 plus 4 gives me 3 square root 5, and that square root of 5 just comes along. Hey, guys, also, square root of 25, what is the square root of 25? 5, perfect, that simplifies nicely. And then the last thing we need to do is combine any other like term. So 4 minus 5 gives me negative 1, and there's my final answer, negative 1 plus 3 square root 5. Here's some steps. Hopefully that makes sense. Shoot me an email or a message on Schoology if you have questions, or save them for the Zoom session about this. So now the last objective we have to talk about is rationalizing denominators, rationalizing fractions, okay? What does rationalize mean? So basically, in math, it's illegal, okay, to have numbers in denominators that are irrational, okay? I can only have rational numbers in my denominator. Nice whole numbers, 2, 3, 4. Nice whole numbers are the only numbers allowed in denominators. when we have a square root, though, that represents a number that is irrational. So I need to get rid of it as soon as I can by going through this process of rationalizing the denominator. Okay? And that's why we go through this process, because we want the denominator to not be irrational. And by doing this, we're going to make it rational. So this would be the type of example we're going to see. Rationalize the denominator. I see this fraction, it's like hurting my eyes because I have a radical in the denominator. It's like using the wrong there in a sentence, right? It's bad English. This is bad math to have a radical in the denominator. So what we have to do to rationalize it, this is the step that we need to remember. Highlight that, write it down. Multiply the fraction by the conjugate of the denominator. So my denominator right now is 5 plus the square root of 3. A conjugate, all it has us do is change the sign of what's going on between those two terms. So instead of having 5 plus the square root of 3, the conjugate is going to be 5 minus the square root of 3. So this phrase, that's all we have to do. Multiply the fraction by the conjugate of the denominator. Here's that multiplication going on. Times, times. The conjugate is the opposite sign of my denominator, which is 5 minus square root of 3. Multiply that to the numerator and the denominator. And this is why we just practiced this previous example, multiplying. Because now, we kind of just focus on this one thing at a time. What are we going to do? How do we multiply something that looks like this? 7 times 5 minus the square root of 3. Hopefully you're thinking, well, Ms. Prosser, I distribute, right? We need to distribute this. 7 times 5 gives me 35. 7 times negative square root 3 just stays next to each other, minus 7 square root 3. Okay, and the same thing for the denominator. Now we focus on that, just like we did in the second example. When I'm multiplying two binomials together, two terms that have two expressions that have two terms in them, we need to FOIL. So maybe this will help see that a little bit clearer. So I need to FOIL, okay? 5 times 5 gives me 25. I will underline. Then we need to do outer. 5 times negative square root 3 minus 5 square root 3. Then we need to do inner, positive square root 3 times 5 plus 5 square root 3. We just write the whole number in the front. Square root 3 times negative square root 3, negative square root 9, right? Radical times a radical, we multiply the radicands, the numbers under the radical. And then we just simplify. So my numerator, I can't do anything with this, right? It's a whole number minus a number with a radical, can't do anything. 35 minus 7 square root 3. Let's take a look at my denominator. What can I combine, right? Take a look at negative 5 square root 3 plus 5 square root 3. Ignore those radicals because they're the same. Negative 5 plus 5, what's that going to be? 0, right? These terms cancel out. It's like negative 5 plus 5, that's 0. And then what about this guy? Square root of 9. What's the square root of 9? Ooh, the square root of 9 is not 9. The square root of 9 is 3, right? So then we can just simplify this, the denominator, and say 35 minus 7 square root 3 over 25 minus 3 is 22, and there's our final answer. Okay? Rationalizing the denominator. All the skill that we need to do is remember this step right here. Multiply by the conjugate. Because we know how to multiply with radicals. That's what we practiced back here. Right? We need to know when it says rationalize the denominator, we need to do this step right here. Multiply the fraction by the conjugate of the denominator. And that's all we have to do. Okay, guys? Save some questions for Zoom or email me, message me. You guys are going to practice this. Awesome job. You guys are killing it.